Hi, my name is Kevin Galligan. I'm a partner at a company called TouchLab. I've been doing Android for quite a while, before there were phones, and been doing Kotlin Multiplatform for the last couple of years, and recently full-time. TouchLab is a mostly mobile dev shop. It's been around since about 2010. We make apps and hardware things, and we're currently super focused on building out a Kotlin Multiplatform focused side of the business. Fortunately, we've had some pretty good partners to begin with, and it's been very interesting working with them. And of course, if your org is interested, we're a consulting company, so reach out. Obviously, that's what we do. So enough about that. Conferences are fun. So KotlinConf had a deadline of May for submissions, and it's currently December. And this stuff moves very, very fast if you don't know anything about it. So somewhere around July something, there was this thing called the relax mode draft PR that was submitted to the Kotlin Native repo. And relax mode essentially is like whatever you want to do, right? It's shared memory. It's kind of like the JVM essentially. So here was my talk, and that was going to be it. Because there's nothing to talk about if it's entirely the same as the JVM, right? But after the PR, and except for like serious debates, really not much has happened in that vein, you know. But a lot of serious debates, and people have very strong opinions about this particular topic. Good news for me, I still have a talk, right? So I was all ready, and I had prepared it and had rehearsed it, and then sort of, not really, that's a lie. I wasn't even close to ready. But then a few weeks ago, this draft PR for multi-threaded coroutines came in. So if you weren't aware, coroutines were restricted to a single thread on native. So most concurrency was kind of a bespoke form or another that worked around that. And that's still true today if you're going to build anything right now. But that kind of that part of the talk had to kind of morph, and I redid a whole bunch of stuff last minute. But this is really good news. I mean, prior to multi-threaded coroutines, you could do concurrency, obviously, but to many people, it was like a psychological barrier. Native wasn't ready, lots of library work wasn't happening, yada yada. But I'm getting ahead of myself. We'll talk about that later. So, intro. What's going on here? Wow, that took a while. What is Kotlin Multiplatform? So I'm out talking about this quite a bit to a lot of folks, and I have this concise definition of why I think Kotlin Multiplatform is differentiated from other solutions in the space. And one of the things is that it's a modern platform. And if you saw last year's KotlinConf keynote, Andre talked about standard concurrency, which I put into the modern, platform space, right? And standard concurrency because concurrency is hard. And if I was going to talk about why concurrency is hard, that would be several talks, that would be books, that would be people's entire careers. So we're not going to get into much detail. But it's an interesting topic that I think the more you know about it, the more scared you are of it. Like junior developers seem to not have a problem with this, but as I had a whole story about, a horrible war story, and I took it out because we ran out of time. So anyway, the Kotlin native model is controversial. There's lots of disagreement in the community. And it's pretty well split. Like some are used to it or kind of like it. Some like super, super hate it. Go check out the talks. But I will point out that the JVM model is also kind of controversial, right? Like many other platforms don't let you just do whatever you want with shared state. So JS, obviously, I wouldn't call it modern, but Go and Rust and things like that, they don't let you necessarily have unrestricted access to shared memory. And the community is not necessarily excited about shared state with threads, right? So you can go read this stuff. It's interesting. So this talk is going to cover how the model works, my thoughts on concurrency and best practices, kind of libraries and future stuff, now with the multi-threaded coroutines. I'm not really going to try to sell you on the model too much, and I'm not going to complain too much about the model. I'm definitely not going to debate various perspectives from the community. Talk to me at the party, preferably after a couple of drinks, we'll talk. And I'm also, in my talk, submission, sometimes I forget what I actually submitted, and I was going to talk about how to get around these rules. I'm not, because you should learn how to use them and become experienced with them, and then you can figure out how to get around them. So sorry, you're not going to hear about the secret tricks. I do know this though, you need to understand it if you're going to use Kotlin native. Libraries will not hide all the details, right? Strict mode seems like it's here to stay, so you should pay attention or read about it later or whatever, learn this stuff. But it's also kind of important, relax. It's not super dire. There's definitely significant adoption of KMP out in the wild, and it's growing now, right? The model itself is not really that complex, and it's very possible you might wind up liking it. Like I see some JVM state now that I just can't believe is left that way. So we'll quickly talk about Kotlin Native's rules. The first one is mutable state is visible to one thread only, right? And this is referred to as thread confinement. If you're a mobile developer, you already know what this is because you're not allowed to change the UI from a background thread, right? It's self-imposed thread confinement. Kotlin Native is doing it in a more formal fashion. And two, immutable state is equal to, you can do many threads, right? No changes, no problems. Yeah, so those are the two rules. And if that's all you get out of this talk too, then you're done. That's great. But in reality, if you internalize those rules, that's very important. I'm getting a phone call. Internalize those rules, mutable one, immutable many. And once you get to practice, that's really all you have to know outside of everything else you have to know. And when you see state like this, when I see this now, I cringe, right? There's this object that anything can call at any time and change some state in it. And when you coded it, you might have restricted it to the main thread on purpose, but 3 years from now, somebody that on your team is going to do whatever they want, right? Spoiler, like the Kotlin native runtime will not let you change that. So you don't manage concurrency with synchronized or volatile, right? You don't have all that stuff laying around. And you kind of shouldn't be doing that too much in the JVM anyway, as our best practice has learned over the years, right? You will do some, like there's atomics and other stuff we'll talk about. But the goal is just not to leave mutable state lying around and trying to protect it with this, this stuff that's hopeful at best. Fundamentally, the JVM trusts you and Kotlin Native does not, right? And it tries to do at runtime verification that you're not going to do something that's super bad with your concurrency. So you do have to do things somewhat differently. But I feel like when I first started and talking to other people that start with this, you're losing some ability, and nobody likes to lose any capability. So there's this initial, I don't like this, and I had it too. But you can kind of do all the same stuff. You just maybe have to do it differently. I will say to JetBrains, it really sucks that you can't do strict mode in JVM, but you have to do it in native. That part of it is not great. I have no idea if it's even possible or feasible to do anything like strict mode in the JVM at some point, but that would be interesting. So you can also kind of break all these rules. And again, I'm not going to tell you how, but there's ways to kind of get around any of them. It's not a great idea. You shouldn't make it your default. You should make it very much the exception. But you're not fully locked in all the time to something and not able to do it. So, all right. Let's get a little bit of code in here and talk about what this means. So, worker is a Kotlin native concurrency queue. It is a core concurrency primitive. You will probably not use this directly very much, if at all. But it's very useful to explain the concepts. I like to think of it like Java's thread. When you first learn concurrency in Java, you will play with thread directly. In your code now, it's very unlikely you're going to be creating threads directly, right? Same kind of thing. So it's very similar to an executor service, or in Android world, like a handler message queue looper kind of situation. This is what it looks like with my wonderful diagram. A worker has a job queue, which is a queue, and it has its own thread that's private to the worker. You have some work that you want to do, and you call execute on this thing. Execute may fail because you violated state rules 1 or 2, right? But if execute doesn't fail, it will eventually wind up on the job queue. And if it's on the job queue, the thread will poll, and it'll pull it off, and it'll do whatever you're supposed to do. And then if you don't do anything with the future, it just gets garbage collected, or you can get a future and get something back later on. That's fundamentally what worker does. Code-wise, you create a worker somewhere in your code, and then later you're going to execute some tasks on it, right? And the task takes a parameter. In this case, it's a string that says hello dog, and then it's going to do something, in this case, print it to the standard out, and you will get this. So let's walk through the parts of what's going on here. This is the signature for execute. It has a T1 parameter, which is the thing coming in. It has a T2, which is the return. It has this thing called transfer mode. And transfer mode is an enum with 2 options. It's safe and unsafe. And unsafe will allow you to share state across threads without checking any of the rules. Do not use it, period, right? I had a whole sidebar explaining why, but again, we're slow on time, but just don't do it. So like, see the blogs, play around with it, you'll understand why. Job is very conceptually simple. It's the thing you're trying to do. It takes a T1 as a param, returns a T2 as a value. This happens on the other thread, right? So in this case, this is the job. There's a future, which allows you to do future things that you would be normally used to. In our case, to be precise, we actually should call future here because the example code was a command line app, which would finish before you got to anything in the background thread. Not super important. The important thing here is producer. It is what delivers the parameter to your job function. Producer is itself a function and not just a parameter. And it takes nothing and returns a T1. Why is it a function? Well, the Kotlin Native runtime will run this and verify the result can legally be given to another thread according to the 2 rules. And if you do it just as a parameter, you would always violate rule number 1. This particular function is of type string return, and that's super simple. But we're going to do something a little more complex, which is a data class with a couple values, a string and an int. And we do the producer function like this, which does that. And the reason we're doing that is because string gets special treatment inside Kotlin Native's runtime. It is automatically frozen. I haven't explained frozen yet, but just saying that. So we want to be able to break the rules first, and then we'll get back to it. So this will run fine. This, if we try to put some data into a local variable in that function right there, this, and then give it to the parameter, the producer function, it will fail with this illegal transfer state. If you're using worker, you'll see this pretty often. You probably won't be using worker, so don't try to memorize it too much. What's happening here is execute wants to transfer some data between threads, right? So it checks the result of that producer function for external refs, right? It looks like we don't have any, and, mentally it's like, well, what do you mean? There's no external refs. But the reality is that block, that function block, still has that data. And state in Kotlin Native is reference counted, so it'll get decremented when you leave that function. Unfortunately, transfer fails because something is still looking at it, right? So I will say that moving mutable data between threads is extremely difficult syntactically in a lot of cases. And most of the libraries and anything that we do basically doesn't do it. We just have immutable state going between threads. Speaking of, this is immutable, right? There's 2 vals. And that is true. It's like source level immutable. But verifying that at runtime, especially with large object graphs, is maybe not going to be cheap. And also, if you could only have things be immutable at a source level, that might be restrictive. I assume that is the reasoning. So anyway, there's this thing called freeze that you can call on any object in Kotlin Native. And it is a runtime designation on the object itself, which says this is like memory level frozen forever, and anything I touch is also frozen forever. This is in native defined on everything, and it returns itself. And what freeze does is recursively go through everything and turns it blue, right? It freezes it forever. There's one-way operation. There's no unfreeze. But once you do this, you can share state between threads as much as you want. So if we go back to this case that was failing, if we freeze that argument, then everything works. Great. Of course, from then on, some data is going to be frozen. And, blah, 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 blah. I had another slide there. I don't know why. Anyway, that works. But if you try to do something like this, like say freeze and then just reference it directly in your block, you'll get this weird thing because worker does a lot of weird stuff, right? And it's kind of beyond the scope of what we're doing. You're not really going to use it anyway. So we're going to create our own little function to help do background tasks called background. It takes a block, and we're not going to pass anything or return anything. It may capture stuff, just FYI. So again, this fails because worker does some weird stuff. And if we try to freeze it, it fails because worker does some weird stuff. So we can try to pass it in as a parameter to our producer function, which we would hope works, but does not because it is not its mutable state that is still being referenced. So we freeze it, and that works. And then we're going to say goodbye to our friend worker because we're done with worker. So now we have a generalized background function that can take a lambda and do some stuff with it, and it will capture state, and it will work, right? So we do this, and in our background, it calls freeze, if you recall. And it's late in the day. If you're zoning out, pay attention right now to the next bit. It will also freeze the state that you've captured in your block. That's not a big surprise here, but where it gets weird is in something like the following. Let's say you had a click model, and your user was clicking on a button and you were incrementing a value for some reason. Not sure why, but that's what you're doing, right? If you decide that that needs to happen in a background thread, it might look like this. So when that user clicks, it's going to run, that's going to happen, which is also going to do that, and that's going to fail. But it's a little bit worse because it's also actually going to do this because you've captured that thing. So now your whole thing is blue and frozen, and then you're going to see this thing. Invalid mutability exception. This is your new friend. You should get very familiar with invalid mutability exception. You're trying to mutate something that's frozen. That's essentially what that is saying. Functions can have state. You have to be very careful with what you capture. That's sort of the TLDR of that section. So global state has some special rules. If you define a val or a var somewhere in open space in a file, it will only be available to the main thread, but it will be mutable by default. If you try to get at it from a background thread, you'll get an exception. Global objects will be frozen by default. You can get them from any thread, and it's the same instance, but you can't mutate any state. On either of these things, you can give it a thread local annotation, which will mean every thread gets a copy, but they're still mutable. And then the other option is for global vals. You can say share it immutable, and it'll be frozen, and everyone gets the same copy. Why special rules? Well, when you get into it, it's not obvious in the beginning, but you can't pass an object instance to another thread without going through Kotlin Native's keyhole to check things to make sure they're okay, unless you go into C code and, again, getting around stuff. Global state can be referenced from anywhere, so it needs to have the special rules out of the box so it doesn't violate its rules 1 and 2, right? So, tips and new stuff. So we're going to say for debugging issues, living with the new model, your new friend, it really, you're going to hate it at first, but you really have to learn to love it. It is trying to help. When you try to change frozen state, this is what you'll see. And I will say there's an ongoing criticism here in the community, which is, well, this fails at runtime. That's why this model sucks, right? If I could paraphrase. And my response to that is, well, yeah, but if we're being honest, a lot of things fail at runtime, number 1. And number 2, it will always crash, unlike your race conditions. So there's other parts of the argument, I can see the point, but it is what it is. So either you have to get used to it or not use native, I guess. So anyway, one thing that's not clear with my samples, among many other things potentially, is that in our simple samples, it's obvious what's freezing the thing that you're trying to change. In a more complex example, it might become very difficult to figure that out. So we have this thing called ensure never frozen. So if you don't know where something got frozen, you can call this on an object, and when it does get frozen inadvertently, you'll get an exception and figure out where it came from. So part of this is going to be really rethinking architecture and having, what I'm kind of calling intentional mutability, which we're still going through a process of too. I did a lot of bad patterns. We're sort of unwinding them, a year later. But you shouldn't mutate data that you get from the database in that class and then pass it to something else. You shouldn't have a bunch of global state that's just open for whatever. It's kind of best practice stuff anyway, but you have to be more careful about it in native, right? So, for example, in our Joy-Con app, we're moving towards sort of this architecture where we have a content model which takes data, raw data, kind of transforms it into something mechanically can be used by the view, and then the view models are platform specific, and they might deal with some kind of view object or maybe a life cycle or whatever, right? These are both enforced, not immutable. They only are touched by the main thread because that's the only thing that needs to touch them. And data kind of goes in and out like this. So the data that comes in is frozen. We transform it into another piece of frozen data just because. But we keep the model objects to be non-frozen, and we're just very intentional about the state, right? So atomics. Atomics will allow you to mutate frozen state. And there are atomics for simple values as well as atomics for object references. So if we took our count model and made it an atomic instead of just an open val, and we froze the whole thing, that would be okay because we could still call this and it would still work because it's an atomic. Similarly, atomic reference, this is coming straight out of the Kotlin native thing. We had some last minute changes, including 5 a.m. this morning because I just won't let things sit, and we're kind of changing a bunch of thinking. So forget what comes out of Kotlin Native out of the box. Atomic Foo is now released with native support, so I'm kind of pointing people like to check out Atomic Foo, and this is Atomic Foo's version. But essentially, you just say, I'm going to initialize the state with some data and then put it into an atomic, and then we're going to intentionally freeze everything on purpose just to be obvious about it, and then even though it's frozen, you can still do this, right, and change your value. That's what Atomic Foo does. That's also kind of what Stately does. I'll talk about my thoughts on Stately in a minute, well, in probably 12 minutes, but I would say don't use atomics too much. Atomics can like leak memory if you, in certain cases, which I kind of explained better inside the source code. Not to mention that performance is not great in a lot of cases, right? If you're using a global service object and a state is going to basically live forever, or you can explicitly clear the memory, like they're kind of cool. But I fell into the bad early pattern of like, I'm used to having global state and I want to be able to mutate it, so I'll implement everything with atomics, and we're like sort of pulling all that, wrong thinking out of our stuff. I don't know, but do what you got to do. So detached object graph. This is when I said rule 1, where you can have mutable state to one thread. It doesn't mean it's like has to be there for all time. You can detach it and move it to another thread, right? It has a producer, and it's very similar to what Worker does, but it's a more generic form. And I am not going to talk about this at all because we don't have that much time, although I'm probably running through this super fast. But also, like in none of my code, no libraries, no production code, and nothing do we ever use this. Everything that you're passing around or state winds up being frozen, and everything else is, intentionally mutable in whatever way. Detached object graph is just something, again, that when I got started with native, I assume would be very common, and it's just basically not used anywhere. So you can find samples, but I don't know if it's going to be used very much. So we are kind of leaning towards, we're kind of calling worker dispatch state. So we're kind of keeping mutable state local to one thread, sort of hidden, and then only a worker or perhaps a coroutine can access it and be sort of the data broker for you, which looks like this graphically. So we have a state worker, which is frozen. We have a question mark, which is going to pass in some data, and then a state container, which is local only to that state worker's thread, which is going to be sort of the holder for that thing. And it goes in, and then maybe you have another thing that comes out and says, hey, I want that thing, and it's going to pull that out like that. So the data is frozen, but the container is not. And this is for shared maps, caches, like what have you, right? So we built Stately's collections with like atomics, and honestly, we're doing a bunch of tests, and like, if you do 100,000 of these calls one at a time, like performance isn't great. But if you do them batch, it's actually pretty good and not too far off from what just a regular mutable thing would be. And compared to doing like maps with atomics, forget about it, it's crazy. So yeah, we're kind of leaning towards that, but it's an interesting pattern to look at. Multi-platform state, so freeze in common. Freeze is native only, right? The concurrency libraries you use will mostly make you not need to ever call this, but occasionally it is useful to have this available. This is like trivial to implement, so you can just do expect actuals, and then on the platforms that don't support freeze or these other functions, just do no ops, right? This is essentially from Stately, which I had to crack this open and like take a hard look at it, and it shows like I wrote this quite a while ago. Like these things should totally be vals and their functions, which was like, so anyway, again, Stately's going to go through a rethink. So we're up to the thing that maybe changed a ton of this talk, which is multi-threaded coroutines. So I'm going to start with some general thoughts, like what does this mean for Kotlin Native? So, I mean, you can obviously have concurrency without coroutines, but it's been kind of a blocker in a few important ways. So, state model clarity. So the debate around relaxed mode and multi-threaded coroutines, like there was a lot of speculation that relaxed mode was introduced so you could have multi-threaded coroutines, right? And of course, if multi-threaded coroutines needs relaxed mode, then anybody using Kotlin Native is going to use coroutines, and that's relaxed mode, and that's it. Strict mode's gone. Well, multi-threaded coroutines works with strict mode. So my guess is strict mode is sticking around, but at least it gives some clarity for like what you want to do as far as like learning the model and building stuff. A lot of library development I feel like was stunted. So not everybody wants to invest a ton of time building a library that's going to wind up being sort of obsolete if and when multi-threaded coroutines ever arrived. So I feel like that kind of held up a lot of library work, which is going to be uncorked and going into early next year is going to change quite a bit. And this is more general, but kind of KMP feels like it's another signal of reality, of realness. This morning they talked about there's going to be an Android Studio plugin that lets you like build and run iOS apps, which is like a huge signal of realness for this. But still, multi-threaded coroutines adds a thing. Because a lot of people ask, like, is this real and production ready? Yada, 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 including Jared, even on Twitter. It does come up all the time, and anything that is an indication that this is becoming a more stable and production-ready platform is good, if that's what you want. So some disclaimers. This is a draft PR, right? There's still some stuff in there. You know, there's definitely some bugs, and I have no idea when it's going to be finished, and I don't know if it's going to change much. And because native hasn't had multi-threaded coroutines yet, and all I do is native, I am definitely not a coroutines expert. So I am probably going to miss out some important details that you would all love to hear about. I might even get some things wrong, and that's fine. Again, tell me about it at the party, or yell it out if you gotta. But I will say this. We were super excited when this happened, and we took the PR and built it locally, and we had Joy-Con SF and yanked out all of our bespoke concurrency and put in multi-threaded coroutines. And I think it's the first thing in the App Store with multi-threaded coroutines, which doesn't matter to anybody but me, but I put it up on the slide anyway. So, overview of what multi-threaded coroutines in native is like. The coroutine is always bounded with single thread, which is not really exactly the same as the JVM. It does have some implications. It is created with calling this thing. On native, you get, it uses a worker underneath your old friend worker. You can actually get access to that specific worker. It's probably not a great idea unless you really know what you're doing, but you can. Default has a single background thread, and main is defined for Apple targets, which is great if you're doing native mobile. And Windows and Linux, there was something in the doc about it. I don't do Windows and Linux native development, so if you're super interested, you'll have to read it. But there's no main target, so I don't know how that works. Switching threads, you would use with context or equivalence, anywhere you can kind of give it another context to run on, or dispatcher. Data passed in, or more formally captured, is going to be frozen. And data that is returned is also frozen if you are switching threads. If you are not, it is not. So, back to our old friend background, who is going to be our super old friend because they are going away. We're going to replace that with a multi-threaded coroutine. So we have to make the function suspend, because now we're in sort of a suspend world, or launch a coroutine, but I just went that way. We're going to switch context by calling with context and giving it the worker dispatcher. And that is going to do this, which is very familiar to you from what background did, because coroutines are not magic and they live within the strict mode model, right? And they have to abide by the rules. Something somewhat more complex. We're going to take some local state and we're going to return some stuff. So here's our local state. We're going to make a new thing that we're going to return, which goes back to here. And then we're going to print it out, right? So it's a little hard to follow looking at that jumble, but essentially we're going to suspend from the main thread. This is going to happen in the background thread. It's going to return some value. We return to the main thread, and then we're going to print out some stuff. It's telling you about dogs, and it's also telling you that it's frozen, which is exactly true. That's how it works. So something probably a little more real world useful. We're going to have a data model that takes an ID as a value parameter, and it switches to a background thread, and it's going to call a database with that ID to get a value, and we're going to print it out. We're also going to call ensure never frozen, because we want to make sure that that thing is never frozen. That is going to fail, because we're capturing that DB ID when we're passing it into the background thread, and it freezes that whole thing, which will fail with ensure never frozen. So that kind of sucks. So you could do this, where we're going to have local state written here, and then we're going to capture that. And that'll totally work, but that's just kind of nasty, right, to have to do that all over the place and remember it. So kind of best practice is definitely going to be when you're switching threads, you're going to want to be like calling a method and having that thing do it, right? So this method is going to do our with context. It's going to take a local parameter value that gets captured in our block, and then we're going to call it from here. The suspend happens, it returns a value, and that all works, which is also a lot easier to sort of read and look at. I've read that that's best practice with coroutines anyway. Not entirely sure. Hopefully it is, but we'll see how that goes. So flow and channel, etc., all the communication objects are also freezable and transferable. So back to our example here. The network calls happen on regular suspends. It's not KTOR currently because KTOR does not support this multi-threaded coroutines preview. I also think that I would love a mode of KTOR or another library that would just let me like not have to get really complex with what thread I'm in and just call something, but we'll see how that goes. Anyway, the database is using SQLite and Flow out of the box with the multi-threaded coroutines. And pushing updates to the database works like you'd expect. You just get to listen to it, and you'll get the stuff. It comes in the background thread, it arrives in the foreground thread, and everything works as expected. So that, in very short summary, is going to look like this. In the init of one of our model objects from the Joy-Con app, we call ensure never frozen, then we get an as flow, and then we also say flow on, and just because I'm paranoid, I want to prove a point, we're going to say it's not in the main thread when we're doing database stuff, and then when it's all done, we go to the update the view, which wouldn't work if you weren't on the main thread. It's obviously kind of simplistic, but it's also all in common code, and it's pretty straightforward, and as long as you like understand and follow the state rules, this stuff is definitely going to work. So, community libraries, I'm just going to generally quick chat about this. This is part of the talk where it was like, gee, I had to change everything. A handful of you are at Toronto, where I essentially just stopped talking a few weeks ago because multi-threaded coroutines changed everything. Anyway, Stately is something I wrote over a year ago, I think. It's not so much multi-threaded coroutines that's changing this as it is the concurrency model is probably going to stick around. I've had a long time to think about it, and a bunch of other libraries have happened and things are changing. So we're going to significantly, I think, change Stately itself. Along with multi-threaded coroutines, Roman also added support for Kotlin Native and Atomic Foo, which hadn't existed up until that point, which is interesting because the merge happened on November 18th, or the commit PR happened on November 18th of 2019, but the original commit happened in August of 2018. So I don't know where that's been, but that's pretty interesting. So Stately v1 will probably be deprecated-ish. A lot of it anyway. I don't really want, if anyone depends on it, I don't want you to have to like go change all of your code. But I also don't really want to like support a library that has a direct JetBrains official like version competitor. So we'll have to figure out something there. And like lock and atomics was a lot of what Stately's purpose in life was. Stately also has collections, which I briefly touched on. I implemented essentially collections like linked list and hash map with atomics, which is not fast. They do work. I was thinking like, yeah, that might get deprecated too. But I also feel like a lot of people coming from the JVM really want or expect to have the equivalence that they're used to, and giving them this weird like confined state model thing out of the gate might kind of push people off. So I'm thinking more like this annotation doesn't exist, but like we'll keep publishing it, but don't use it kind of situation. We'll see. That's like a January thing where we're going to talk about it and figure it out, but we got the holidays in between, and so we'll see how it goes. But definitely a lot of rethink about Stately with a year and change of experience. So coroutine worker. It is today. If you're going to build a Kotlin native app, absolutely, this is something you should look at. I know of more than one app in production that is super happy with how this works. It's essentially helping you do concurrency with coroutines, with workers in a single thread, but across threads. So I don't know, Ben is here. I'm not sure how multi-threaded coroutines is going to impact this, but it's definitely, again, like I think a lot of stuff's going to be changing. I also wanted to mention reactive, which I've talked a lot with the author of reactive. It is a reactive streams port, which does work on multi-platform. It seems like it's fairly popular. We haven't really used it just because we haven't needed anything really that heavyweight. And there is a PR that's going in there where they're going to do some multi-threaded coroutines integrations. But again, see how that all goes. The next few months is going to be pretty interesting to see how things change. So anyway, next steps. I have a couple of blog posts that are starting to get pretty old, but they go over the same topics I talked about here. There was a third version that was supposed to talk about how to do all this stuff in Common Code, which I never really got around to. So I know I'm like signing up for a whole bunch of crap in January, but I'm also going to update those and try to write that third one. We're also kind of moving off of Medium, so they'll all get like a repost, which should be pretty cool. But read them now if you want to see this again in detail and have a little longer explanation about why you shouldn't use unsafe, about how the reference counting works, that kind of stuff. JetBrains official links. So in the Kotlin Native repo, there's a talk about immutability, talk about concurrency. There is a talk last year from Nikolai at KotlinConf. He is the head of that team. It is authoritative, but you should definitely watch that when you understand this, because otherwise it's going to be, it's like the really deep level stuff, just saying. I brought a bunch of people there who had never seen it before, and I'm not sure that they left less confused about it. So, but it is good. It's very good. And then also just go read the doc in the branch from Kotlin X coroutines about this. I put it under our branded link because it's like super, super long because it's in a branch. But go check that out. There is no Kotlin cones for native concurrency or native state, and we're advocating with JetBrains that they should really make that. So if you want that, I highly suggest you kind of let them know. I think it's very useful because you can watch this, but you're not really going to understand it until you start playing around with it. So, or you just have to find samples and do whatever. But the cone stuff is pretty cool, so we're hoping they do that. And then, I don't know, kind of check back in January, because again, I think the coroutines release is going to trigger a lot of folks taking a deeper look at this and publishing stuff and talking about it. So that's my advice. If you want to try out multi-threaded coroutines now, there is some assembly required. You have to do sort of a build and deploy locally. That might change tomorrow, I don't know. But as of right now, there's a couple of necessary fixes that are in the repo. So go do this, go into your directory, run that, publish in Maven local, and it'll take a while, but that should build without any issues. So there are a couple of samples you can probably try now, and there might be more official ones that I'm just fully not aware of, so apologies. From this talk, I essentially have like the scratch work I did for the slides, which is not guided in any way, but you can go poke around and check that out. And then there's the DroidCon app, which has more interesting stuff, but there's a whole bunch of other crap in it, so you have to figure out where everything is. But you can check that out and go to that particular branch and poke around and see how things work. So the other things I'm going to tell you about are TouchLab is building this thing called the KMP Evaluation Kit. And the idea from this came because we talked to people that are evaluating Kotlin multi-platform, and often in the form of, let's say, a hack week, and then they read a bunch of blog posts that are old or conflicting, and they try to do a bunch of stuff, and it's like Thursday before they're compiling anything. Our goal is essentially to accelerate that to at least Monday afternoon. We are a consulting company, but this is free, so just go sign up for it. I'm also committing to do this sometime in December, so I've really ruined the end of my year. Go here, sign up. It is a consulting company, and I have to give them some leads, even if you're not real leads. So give your email address, but you don't have to buy anything. Just FYI. And if you come to the party, we got some weird stickers with all the spaceships on them. So come grab them from me or up on stage. Remember to vote. And that's it. That is my contact info. And I'll wrap up with saying that we are actually now with real clients, one starting Monday, which I just found out, for real, hiring Kotlin multi-platform specific engineering positions. I know most people don't have experience, but if you're super curious, maybe reach out about that.